afternoon. We do not have a lot of time. We're doing a quick midday stream. Let me open up my stream manager here to get our battery test rig all set up. So I'll go through some of the code changes that we made here recently. But first, what we need to do is we're going to switch to the overhead here and say, let's go through the code briefly. So same as last stream, with just some additions that I found in a GitHub repository issue where they talk about doing like a calibrated read. So every ESP32, the internal reference voltage I said in the last stream was 1.1 volts. It's around 1.1 volts. Every individual ESP32 is slightly different. And so it may be instead of 1100 millivolts, it might be 1128 millivolts or 1090 millivolts. And you can get that calibration information to really hone in your analog to digital converter. I don't really care. I don't need it to be super accurate because I'm not doing an application that needs it to be super accurate. I'm just trying to get the voltage off of the battery. And so I just use my reference voltage of 1100 millivolts. So write what it's supposed to be. And then again, if I want to change this later with a firmware update, I can and put calibration information into a partition on the device. And so we have this analog read calibrated. And so all it does is, again, I copied and pasted this code. It's going to use the actual raw ESP32 calls to pull the voltage. And then it's going to count down like we did before. We're going to set the resolution to 10 bits instead of 12. That, according to forums, makes it a little less jittery when it reads. And again, I don't need this to be spot on. I just need it to be close so I can keep an eye on the battery level. And then we're going to call this ESP80C cal characterize. And that kind of, well, actually, I don't even know what it does. I copied the code. And then I added this analog read cal here. That's that new function that we just passed up above. Because for some reason, the very first read of this is way off. I don't know why. I've put a delay. For whatever reason, the very first call of this function is way off. Which, if we go back and look, does it have any sort of like static variables that it... No, it shouldn't. All right, well, I don't know. Okay. Anyway, so I put one up here in the setup function to get that sort of garbage reading out of the way. And so that when we come down in here, I set up a little bit of memory for our JSON that we're going to send to IFTTT. And we call our function after we're connected to the Wi-Fi. I'm using the 0 dB attenuation because, again, I'm voltage dividing this down into the range of 0 to 1.1 volts. And then I'm going to serial print it out. You can kind of see it over here in testing. And then I'm going to set up the HTTP call and send the JSON right here. Okay, so that's how we get it there. Now what we need to do is switch to the overhead cam. Okay, so what we're going to do is I've got my resistor divider set up over here. All the stuff on this half that my finger's covering right now, you can ignore. That was from a previous experiment that I was doing on a different device. And so what we need to do is we need to attach ground, which is going to be right here. The pin to read from our analog to digital converter is going to be right there. And then what we need to do is get the battery. Well, the battery, get my pointer out. My battery is right here, the voltage that comes off of that. So what we need to do is we need to solder a little wire onto there that we can then plug into over here, basically this. So we want to plug this red wire into this right here, and I could just sit here and hold it like this, but the idea is I want this to run for 4 or 5 hours and watch the voltage change, which I got working. Let me show you that briefly. Here's the Google Sheet. Pull it over. So what it does is it starts plugging values in, and then the chart here is just going to chart that. And so over time, you cannot see that. Jeez. Okay, here we go. It puts values over here, a time and a reading, and then it shows what, it just graphs that over time. So that's super cool. We're going to go ahead and get all of the existing values out of there because that was just testing. Pull this back over and out of the way. We'll switch back over to the overhead camera. So what I'm going to do is I'm going to turn my solder station on. And I apologize, when I come over here, my voice is probably getting a little lower. Based on OBS, you can still hear me, but the audio is probably not going to be as great. And what we're going to do is we're going to create a female connector that we can solder right to here and then plug this into. And to do that, we just need some fancy stuff that I bought a while back. Come into the... So what I do is I'm going to just break off one of these female pins, drop that in there, and then we'll need a case for it, which I have a bunch of here as well. I just got these from Pololu. I'm not sure if that's how you pronounce it or not. It's a little maker shop on the internet. One of those. Then I think that's all we'll need here. And then what we need is some wire. So let's go grab that. We're going to need those. We'll just take some flex wire here and get our wire strippers. And we don't need much. So we'll just cut a little bit off of there. Just a little piece of wire I just cut. We're going to strip one end that we're going to solder. I believe this is 22 gauge wire. We don't need to strip a lot. I'll try and do this in camera here. There we go. A little bit of wire there. How are we doing on time? We're doing okay on time. We gotta hurry. I gotta go pick a child up from an event. Okay, I stripped a little bit too much off, more than I'd like there. You can see we're gonna unplug all this while we solder. That's a little bit too much. I'm gonna cut that down. Okay, and now what we also need to do is we need to strip the other end back. I probably could have used that end that I just stripped. I wasn't thinking. Okay. Set our wire strippers down over there. Okay, so now what we've got here, you can see, this is the end that we'll solder to the board, and this end right here, we can put inside. I don't know how well you're going to be able to see that. It's probably not going to autofocus, but basically what we do is we stick it into here. I need to twist that a little more. Doing this on camera makes it a little extra difficult. Essentially like that. And then what we do is get this just to the right spot. And we push it in like that. And if I have it all in right, which I don't believe I do, let's go just a little further. I don't know, let's try and crimp that. Just crimp it down until it clicks. And then you're left with that. And if we inspect this, ooh, it looks like it damaged a little the clip. Let's see if the clip slides on. I think I might have damaged it. Yeah, I bent it up a little bit there. I think it's going to go in anyway. There we go. And just like that, we have our own custom connector that this will plug into like this. Just like that. Pretty handy. And I'm trying to shove this in just a little more. Oh, I bent the thing that holds it in. All right. You know what? I think it's going to hold though. And I don't even need it to be in the holder. Just need it to plug in. Which it is too bent to do. Okay. All right. Screwed it up. Do it again. We'll cut this one off. We'll restrip it. And we'll do it again. Okay. All right, let's try this one more time. Okay. The soldering iron's over here like boiling hot, ready to do its thing. All right, I'm gonna do this off camera this time so I can keep my focus on making sure I crimp it right. You got the idea the first time there of how it works. Okay, I got it in all the way this time. Okay, that should be, that's a great crimp right there, I think. Stand by. Okay, we're back. All right, where were we? Okay, that one was much better. Let me switch back over to the overhead. Okay. All right, this one is going to slide in just right, I believe. You know, it should click in for you. Which it's trying to give me a hard time. Okay. That's in just like we want it. This should connect just fine. Yes. Yes, it does. Okay. Man. All right. Now, let's get our soldering iron up here. And let's solder this right onto the, let's see which is which. Yeah, the positives on the outside here. Okay. get our iron. I have no idea how well this is going to work with all this equipment in the way. There we go. Seems to be okay. All right. Now we're going to need just a hair extra. Oh, you know what? Sorry, this is going to get loud. I got to turn on the smoke absorber. Oh, you can't really even hear that. Probably when I talk you can. Okay. Okay. I always put a little dab, excuse me, of solder on the tip when I'm done with it to help with corrosion. I heard that once in a video, and I've always done it, and it seems like it's done a good job. I've had the same solder tip for a long time. All right, that's it. We're good to go. We've got that is attached fairly well. Let's just make sure we don't have any shorts to our other pin. Great. Okay. Let me get all these tools out of here. How are we on time? We're getting there. Okay. Let's now we're gonna hook it up. So the way we're gonna hook this up is this is the ground pin. We're gonna hook it up to the second because that's where ground is on our schematic. We're gonna hook up the battery to the top side of the voltage divider. It's that little connection we just made there. Really nice. And then this yellow is the actual output of our voltage divider. That's going to go into the third pin, just like that. And then this white wire I have out here as a way to hook up my meter, which we're going to do to see what the meter says we're reading. And I'll try and slide that in right here. Low on real estate. We're going to hook to ground. That's this one. And then we're going to use the other one to hook right into the middle, the same yellow wire. And that should give us, excuse me, that ought to give us the reading out of our voltage divider. Great. So now all we need to do is, let's turn our meter on. The meter is old school. My dad gave this to me. He used to work for the power company years ago, and this was an old meter that he gave me from work. It's, at least 15 years old, at the very least. Probably closer to 20 years old, so been serving me very well. All right, both of these batteries that I have here are fully charged. So they are at 4.2 volts. Again, we're voltage dividing those down, and we'll later look at the exact values of the resistors to get a better idea of what we should multiply by to translate that 0 to 1.1 volts up into the 4.2 volt to probably realistically down to 3.2 volts for the battery. And so what we're going to do is let's program this first of all. Did we make any changes? I can't remember. So I'm going to hold this in reset. I'm going to plug this in. Oh, I'm going to keep holding it in reset. I'm going to plug the battery in and try not to electrocute myself. Okay, plugging the battery in is proving to be difficult. Let's just program it. Okay, we're gonna let it program. I know you can't see that screen right now. All right, programming is done. I'm gonna reset it. Actually, again, I'm gonna unplug it. And, oh, you know what? What am I thinking? I don't want the USB plugged in at all for this. I just want the battery plugged in. Because if the USB is plugged in, it's gonna charge it. And I don't want it to charge it. I want the battery to go dead. So, now that it's programmed, let's grab that and slide it over here. What I'm gonna do now is I'm going to plug the battery in. So the battery will be the sole thing powering our hardware right now. Like that. Okay, and you can see it's right up near 1.1 volt because the battery's at 4.2 volts. And so it should be around 1045 millivolts. And you can see right here, you can't see, let's come back over. We're starting to get data. We're not going to get serial output anymore because we're not connected to serial. But we're going to, our data in our Google Sheets is going to start filling in. So you can see the first reading came in at 1032 millivolts. And quick comparison, the second one, again, 1032. And again, it's not perfectly calibrated because I'm using the straight 1100 millivolt reference voltage where it's never perfect. And so if I calibrated it, this would be even closer, but you can see consistent 1032 as opposed to what we're seeing on the meter here, which is 1044 millivolts. So really close. We're talking, what is that? A 12 millivolt difference. That is not something that I am worried about. And so I don't know why it's being dumb and saying no data. Like, oh, x-axis, select a range. I learned this today. If you do B, that will be like the entire B column. You don't have to do a start and end. So if we plug that in, no, it doesn't. I did that wrong. Let's try again. Data range, and if I just select B, yeah, B:B. What are you talking about? I don't know why it's saying no data. So I played with this a bunch. You can't see that again. I played with this a bunch earlier. These charts are finicky in Google Sheets. Like, I don't know. They're kind of, I've not been impressed in the little bit that I played. So the data range is B1 through B1013. And the range is this. Why it's not, I don't want to use column B as labels. Maybe that's why. You know what? Honestly, I couldn't tell you. Let's just refresh it. It's working. No data. So watch this. Let's just delete it and say insert chart. I don't know why it just decided to give me a pie chart. Let's do a line chart. And we don't want to use that as labels. We want our range to be sheet 1 B. That's so okay. And it still has the old range. Delete. Okay. There we go. This is exactly what I want to see. Great. Okay. So now, as you can see, it's just going to keep updating, and my data will just keep on cruising. So you can see it's steady right there. I'm impressed that it's just staying right there at 132. Very consistent. If we come back over to our overhead, you can see this is still at 1043. So, you know, again, 10, 12 millivolts off. That's not a big deal. We're not worried about that kind of a difference. And what we should see is as this updates over time, because it's going to be sending Wi-Fi over and over and over, that battery voltage should start to drop. And I'm thinking, I have no idea how much current this is using right now. I'm imagining when it's communicating to IFTT, if this then that, it's probably somewhere on the order of 200 to 300 milliamps, but it's going to be for a very short amount of time. Otherwise, it's only like 20 milliamps. So this could run for a lot of hours before the battery starts to really go down. I guess I could add some other heavy computational stuff to the sketch, but we're going to let it sit, run like this for a few hours. We'll be back streaming again this evening. You can join us. We're going to check in on this, as well as start making some of the printed circuit board changes over here. We're going to be placing these resistors because I'm feeling pretty good about the functionality working as we expect. And yeah, making some of the other tweaks to the hardware so that sometime, hopefully next week, we can get this sent off to fab and assembly to get some boards in to start testing with. So that's going to do it for the stream this afternoon. Just a quick one, getting all this test jig things set up to test the battery, and we'll let it roll and let Google capture all the data for us. So thanks for watching, and we'll see you again this evening.